I do work with other people, mostly I support these organizations. And I do, cover manufacturing operations, through it, vice president, and then I manage a lot of our sites.
Well, by the way, I think it's incorporated. Oh. Wow.
Oh, really? Okay. Oh, okay.
Michael, hi. Thank you so much. Hi, this is Joe Sylvester. Nice to meet you. Hi, how are you?
So just getting the clicker set up.
Okay.
The video post
The animation?
no, the video.
Which video?
Sorry, you're right.
That's fine. Hi Joe, how are you?
Hi, good. How are you?
Good to see you.
You too?
This is just a little thank you for speaking.
Oh, thank you.
Yeah, thank you.
Very nice.
So I'm just going to say, I do have a parent who's coming to do bar to 11. So I'm going to just pop out at like 5 till. I don't want him to think I'm being rude.
So we're going to do this right before I start? Or?
Yeah, or like, do you want to introduce?
Yeah, I'm going to.
And then you want to come up and I'll just launch the video and.
Yeah. So after the introduction, I'll play for a second. So everything work with John?
I just got a little variable in the name.
Yes.
Try it.
Oh, okay. Nice to meet you. How are you?
We had some ITSD for us to make sure that
Playing the whole animation, right?
and I'm just doing
The, North
No, I don't think it.
No, because I think Laura took that out. That's why.
She did? Try it. You have to go to play. You have to go to play. No, I don't think I'm going to have time. Keep going. Oh, okay. It's not there anymore. Okay, that's right. Because we had to cut slides.
Yeah, exactly. I mean, if we really need to, I can just do my computer, pull it out, put it in. Okay.
Yes. So we have till 11:20. So I'm going to try to do 30. I'm going to try to do 30 minutes. And the approach I thought I would take is I'm just going to go through what we're doing. So we're going to do a big project.
Okay.
And the biggest part for me is the industrialization. Revamping factories and getting supply chain. So I thought, this is a real life example. We have a great new product. And we're just certified last year. Right. Now we're
Perfect.
this class. Right.
All right. Thank you.
Is that?
Yeah.
We're talking about product realization,
Yeah.
and then how do you turn that into something?
Well, that's why
You're now going
we're doing it. Yeah. And then what? So that's what I'm going to say is like, so this is what we're doing. So we need to extract, from what we're doing to how it applies to your project and how you get it used. Is that okay?
Yeah.
Okay. Good.
We have 2 more minutes.
So what I'll do is I'll just stand up here, watch the video, get it
Oh, really? Is it that one? We had a panel discussion last year. I was like married, but Mary Catherine. Okay. Very sure to cater before I will check.
wrap up, and then I can crack it down.
Hi, nice to meet you. How are you?
Karachi.
Hi, nice to meet you. I'm Joe. Reading
All
all
about classes is about 20, but this brings three together.
Yeah, and actually the other sections, Nina and I, they will also have access. So they kind of watch the lectures.
Right.
So it's all right that we could,
Yes.
it only be seen by the class.
Yeah, as long as you use it that way, it's fine. Yeah. I was surprised that we got okay. So let's run with it. I'll try not to swear.
I was in a big corporation myself. I know exactly what it's about.
Don't become a YouTube sensation. You're not going
Yeah, right, yes.
Exactly.
Corporate people never want that.
You see what happens with the big companies. I have Cindy
know,
marshalling
right,
me.
right,
We got the
yeah.
presentation. It's checked for ITAR, legal, everything. So that's all right.
Joe, I can sneak out like 5 hours to meet a parent.
Okay.
That is what you're saying.
That is boring, and got to get back to work. Yeah. Thank you.
They lose their mommy, she heard. She's, oh my God.
We don't have any announcements, right?
Oh my God.
Hold on. Hold on. I have to go back. Okay.
All right, everyone, we're going to get started. We have a very special guest today, and Dean Mancione is going to introduce him.
Hello, everyone. So we have a lecture on manufacturing today, and for this, we have one of the nation's true experts in manufacturing. I'm very happy to introduce to you Joseph Silvestro. He's Vice President of Manufacturing Operations for Pratt & Whitney. Joe's responsible for leading and assuring the quality, delivery, and cost performance, as well as the capacity expansion for Pratt & Whitney's manufacturing sites. Joe is in charge of facilities in East Hartford and Middletown, Connecticut, West Palm Beach, Florida, China, Israel, and a number of other locations. Joe joined Pratt & Whitney in 1985, and since then he has held positions of increasing responsibility, including Vice President of Pratt's Rocketdyne operations and their supply chain management. Most recently, he was Vice President of Rocketdyne's enterprise operations. So last month, Joe was named to the Department of Commerce Manufacturing Council. This is a 30-person team which serves as the principal private sector advisory board to the Secretary of Commerce on policies to strengthen U.S. manufacturing. So he is truly one of the nation's experts and advisors on manufacturing. Joe Silvestro has an MBA from Purdue and a bachelor's in mechanical engineering from University of Hartford. Please welcome back one of our own, Joe Silvestro.
Good morning, everybody. We like to start with one of our favorite things to do is a video. So let me just start with that and just give you a little taste of the products.
Okay, good morning, everybody. So it's really good to be back here at the University of Hartford. So I finished my mechanical engineering degree here, and so it's something I'm very proud of. And I will tell you, just imagine, I'm an engineer, mechanical engineer. I build jet engines and rocket engines. What can be better than that, right? Fantastic, and it's been a great career. And of course, I either was lucky or made a good decision, or whatever you want to call it, and joined United Technologies and Pratt Whitney, which of course has been enabled me to do that. So today, what I want to do and try to convey to you and maybe help you in terms of what you all are studying is what we're doing. Okay, this is real life. What I am working on today, in terms of we have a new product, and we've got to bring it all the way through to high rate production. Okay, and so what I'm going to do is tell you what we're worried about, what we're working on, and so on, and then hopefully, because everybody's probably got different kinds of projects and so on, you can extract themes that will help you in terms of what you're working on, and maybe hopefully enhance it as well. But I got to tell you, as usual, I've got another motive. I want to excite you about our products. I want to excite you about our company, because most of you are going to graduate, and you're going to be looking for jobs. And of course, we would love to have you at Pratt & Whitney. We would love to have you at United Technologies. And my recommendation will always be to fight really hard to get a job there. I recognize that might not be what everybody wants to do, but at least I'm honest. I want to be honest about my intentions here. So, just a little bit about United Technologies. Such a big presence here in this area, and you may know a lot about the business already. But the company is a corporation made up of a handful of key businesses. One of the things to note about United Technologies is that the names of the companies, Pratt & Whitney, the founder was Fred Rensselaer, Carrier was Carrier, Sikorsky was Sikorsky, Otis was Otis. We're made up of a company of technological pioneers. Okay? We created, or the fathers of those businesses, created the industry that they're in. Okay, United Technologies is about 212,000 employees worldwide. Last year, the sales were $65 billion, and I think pertinent for this class and really for our region is that United Technologies spent last year, 2014, $5 billion on research and development. We're a technology company, and you have to continue to reinvest and push the boundaries of technologies. And what I work on is really, after all the technology work has been done, all of the research that allows us to get into a new product and to bring it to market, right, to manufacture it. I will tell you, I started my career at Pratt as a design engineer, and then, one thing led to another. How do I move this? There we go. Going the wrong way. All right. I talked about this a little bit, but for Pratt & Whitney, Fred Rensselaer started the company in 1925. In 1927, produced for production the Wasp. It was a very new concept for airplanes at the time. It was a fledgling industry. It was air-cooled. So today you say air-cooled, what's the big deal? But the airplanes at the time were using water-cooled engines. And this engine had a thrust power-to-weight ratio, which was significantly better than the engines of that time. And then also, because it had less systems, water systems and so on, it was more reliable. And so from that time period, actually the motto of the company, dependable engines comes. What's really important about that engine, though, is the double Wasp, which was an evolution into the 40s, powered the United States Air Force through World War II. Today, we enjoy air superiority worldwide, okay? And it's based on the capabilities of our jet fighters. Today, Pratt & Whitney makes the engine for the Joint Strike Fighter, and we make that here in Connecticut. And the lineage of that air superiority goes all the way back to World War II. During that time period, Pratt & Whitney made 165,000 engines, the double WASP, to power the aircraft for the Allies as well as the U.S. In that period. We have a lot going on in terms of projects here at the company headquartered in East Hartford. And so this kind of begins, what I want to talk to you about in the sense of you have the concept and the idea, and then we design and we certify, and then we have to bring it into production. But if you look here over on the left, these are just different big projects. So the C-Series is an engine for an aircraft, a new aircraft being brought out by Bombardier, is an aircraft manufacturer out of Canada. And they make small to mid-sized airplanes, single aisle. You might have been on them. They can hold anywhere from 30 people to 60 people, but they're very important for regional transportation. The V2500, that's an engine we've had for a long time. We made a performance upgrade, and customers will pay for that. Okay, so it's a big project because you have to certify because people are flying on this aircraft, and we have to make sure that it's safe. This is a helicopter engine. We are working on upgrades to the Joint Strike Fighter. This is a big tanker program for the military so that they can have fuel to refuel the fighters. And then over here really is what I want to talk about the most today. Airbus A320, and that's this aircraft that you see here, is a very, very popular aircraft today. Airbus sells, manufactures about 40 of those aircraft every month. And they're sold out right now till 2020. Just, it's incredible. And what we've done is designed a new engine for that aircraft that has got significant performance benefits. Such that, just as an example, every aircraft will see more than $1 million a year in fuel savings. And then there's other benefits such as utilization. I'm going to talk more about that in a minute. But these are all very, very big projects with hundreds, if not thousands, of engineers, program managers, project managers, and of course, when you get into the factories, the machinists and the technicians, the manufacturing engineers, the quality engineers, all focused on bringing these projects home. So, our product, what is kind of driven, what is new? So this is, you're in the process of designing a project. This is our project that we're bringing to the industry. Turbofan, have you had the turbine class? I was going to look, I think I have my book, that was a June, I think it was a third year course, so I'll just talk briefly about this, but this is a cross section of a turbofan jet engine. So the fan here, and as you can see, there's kind of an outlet here. So the majority of the thrust of an advanced turbofan comes from what is produced by the fan here. And, we've all seen them. You've been on you've been on airplanes, or you've seen airplanes. What we've done differently is Pratt & Whitney uses a two-spool, what is called a two-spool approach. And so on the inside here, this is all connected by one shaft. And then the back and the front is connected by another shaft. So the long shaft runs inside the short shaft. Okay? And what that means is that the fan runs at the same speed in a conventional design as the back end, and then the middle portion of the engine runs at the same speed. The problem is that the fan really wants to run at a different speed to really get the optimal aerodynamic performance and weight, because if you spin it too fast, you have to make these things heavier. It really wants to run at a different speed than the low turbine at the back end. Okay? And so for years, we've basically sub-optimized. You try to find the right point for weight, thrust, fuel performance, noise. Where we are changing the game is we've inserted a gear. Okay? And so we've decoupled the fan from the low turbine, and we're now able to spin the fan at the speed that it wants to most efficiently run at, and then we could spin the turbine at the speed that it wants to go. You say, what's the big deal? Gears have been around forever. They've been in our cars, or in your bicycles, or everywhere. Well, the power density that gearbox has to run at is incredible. Okay? And they're worried about heat input, how can you get the heat out fast enough, the durability of the gears, and so on. So really over the, we were saying 20 years, 5 years ago, so really over the last 25 years, the gear technology and the know-how has been developed to bring that along such that we are confident enough to design an entire engine around it. So you look at it and you say, look at that little part right there. And in the end, it's, part looks like that. But the whole engine is designed around the gear because you got to match speeds, right? So you kind of decide what cycle you want, and then you start, designing the rest. So to say that this was a significant bet is really an understatement, okay? And there were some analysts on Wall Street that were saying Pratt & Whitney has bet the company on the introduction of this new technology. So bet the company kind of means this doesn't work, we'll be going out of business, at least in the commercial arena, okay? Because we have a very strong fighter arena, okay? So some of the things that help it are the fan, and then efficiency in the core, because you're able to spin. The low turbine wanted to spin faster, and we just couldn't. You couldn't spin the fan as fast as you wanted to. So what has happened? This is specific fuel consumption. So fuel burn. It's a measure of how we measure in a standard manner, and have the ability to compare engines in terms of fuel consumption. So back in the 60s, conventional. This curve, and these dots here are Pratt & Whitney engines, over time, just to provide some, general, and we've been coming down the curve with improving our designs, better aerodynamic designs, better materials, so that the engine could either, spin faster or you could be lighter, and that helps as well. What the introduction of the gear into the engine cycle has produced as a step change in performance. So we're jumping the curve here. And so, maintenance costs, there's other benefits to this. There's fewer stages in the low turbine, because if you're going to spin it, the low turbine slower, but you still have a certain thrust that you're trying to get out of the fan, it's hard to get all the work out with a few stages. So you end up adding stages, which means you add weight, which ends up impacting your fuel burn. So what we're able to do is get fewer stages. And actually, if you're an aircraft operator, when you go in for maintenance, you have less parts to break, less parts that you have to have serviced, and those kind of things. Fuel burn is 15%. So I showed you the V2500 early on. I said we have a lot of projects going on. We spent $200 million to improve the efficiency, the fuel burn of that engine by 0.5%. And customers pay for it. Okay? So 0.5% as compared to 15%. And we developed it for $200 million. That's how valuable it is to the customer. We wouldn't do it if the customer wouldn't buy it. So we're introducing a product that is 30 times that in terms of the benefit to the business. Okay? So when you talk about a technological leap, this is, we haven't seen anything like this ever. Okay? The other benefit is noise. We're able to spin the fan at an optimal, in an optimal way that actually lowers the noise. And so it's good for all of us, of course, but the real benefit is this. If you're in a metropolitan area, aircraft are actually limited in terms of how early they can take off and how late they can land. Okay, because all the people that live around them don't want to have all that noise, and so you have a really expensive aircraft, $60, $80, $120 million, depending on which aircraft it is. If you could use that aircraft 2 hours longer in the beginning of the day and 2 hours later, as an example, the utilization is fantastic. You need less aircraft, say, or you could have more convenient schedules for your customers. There's a whole host of opportunities that can come. And that, for your projects, is always something to think through, is have you considered all of the potential benefits, either the upstream or the downstream benefits of what you're bringing to the market. And then in terms of green, CO and NOx, we're burning less fuel. So less into the atmosphere in total. So the market reception has been fabulous. To date, this year, we've sold more than 6,000 engines. And just to give you an example, this year, I'll produce about 500 engines, just roughly. And we're continuing to sell. Airbus, Embraer, Bombardier, those are the aircraft manufacturers. MRJ is a Japanese firm, and Irkut is actually a Russian firm, that they're designing a new aircraft to have this engine go on. And in terms of the design philosophy that we used, we made it scalable. So if you looked at this is the thrust of the engine. This is 14,000 pounds of thrust to 17. So that one engine can produce in that range depending on how we program it. If you looked at the engine, and especially the cross-section, it would look the same from this class to this class to this class. Now, when I say the same, I think between here and here, there are size differences. But when you looked at the shape of the airfoil and so on, so we kind of say we've got like a 98%, identicality. And so a lot of the parts are the same, which could help us when we mass manufacture, okay? But at the same time, we engineered, the engineering of the different product models was, we solve the problem here, and then you make the tweaks to optimize it for size. So the development costs were lower because of that. So we were able to develop 5 engine solutions for, I don't know how to make that calculation, but it wasn't for 5 times the R&D. It was something much less. Okay, so no good deed goes undone. So we sold all the engines, and now we got to make them. Okay, and this is kind of where I come in at this point, and is we're going to over this period here, the 6-year period, we're going to double our output. So from about 500 engines a year, a little bit more, and it's actually looking like it's probably going to be more like 1,500 engines a year. And this means our internal factories, it means our supply chain, and all of that. So some of the considerations, we want also to not just figure out how to make more, but we want to be better as a company. We want to have our factories in the business overall be ready to be competitive for the next 25 years. Because this is such a big change that you don't want to say, well, this is the way we did it, in the 1990s, and we're just going to continue to do it that way. No, so we want to enhance our capabilities. We've got to work on our manufacturing network. We've got to bring them along. I'm going to show you in a minute. We make a lot of parts, but we make really a very small portion of those. Capacity, continue to innovate in the manufacturing arena, and then cost. This is a business, and we have to make money. If we're not making money, there's no business. Okay, I just want to show you. I had to take the numbers off here, but this is a real challenge. Right now, when we add up the costs, both for what we're making in our factories as well as what we're getting for quotes from suppliers, and even though we negotiate with the suppliers and so on, our cost is here. When we came up with the business case, you do a business case and you say, hey, it's going to cost us $4 billion to develop the program, but we're going to be able to sell 10,000 engines, and the business case, you get an ROI. It's just worthwhile for the shareholders of the company to invest in. And you can see that, and so we have a gap. Now, of course, when you start making the parts, you'll find a way to get better and so on. But this is the reality of the business. Even though we had a product that was better than anything in the market, there's still competition. You know, it's the free economy. We have General Electric, Snecma, fantastic companies, really competitive. They're not going to let us run away with it. You know, by the way, that's a whole other conversation. We don't want to have the whole market as well, because there's other dynamics there that, you know, make it more difficult for us. So this is something that you have to understand. Where are you going to come out of, where are you going to come out in your initial product cost? Where do you need to be to make it viable in the marketplace? We make a decision on make or buy. And we've got a philosophy which says, you know, really our new technology, I call it the special sauce, that makes our product differentiated. We don't necessarily want to share that with anybody, okay? But quite often we'll find that anyways, the number of suppliers in the marketplace that have that technology or is not there. So we tend to make more parts up in this region of the curve. If there are a lot of suppliers and the IP and the technology is low, it's more like a commodity, and of course we source that, and we go out and just try to get the very best value. So this is a consideration as you bring your product from, you know, concepts. It's going to do a great job, but then you have to start making these kind of decisions. All right, we have a global network, which is a benefit to our business. It's been developed over the 90 years of the company. It helps us be closer to our customers. It helps us be closer to low-cost labor. It helps us be closer to other companies, whether it's low cost or not, that have technologies that we feel can be beneficial to our business. So with this 20% make, you can see that we've got factories and or joint ventures all over the world. And so we have to make a decision about where of the parts that we are going to make, where are they going to be made and why. That's a consideration. And I just wanted to, you know, point out, you know, when I look at the project that I'm talking about, these are the key factories. They're real factories. Okay, there's about 10,000 people that are tied up here when, you know, on this slide. But you know, this is Connecticut, East Hartford, Middletown, North Berwick, Maine, and West Palm, Michigan down here, Canada in Longueuil and Maribel, Rzeszów in Poland, and Kalisz in Poland, and Krakow, Chengdu in China. So these are all factories that are going to be involved in this project, but not all of the factories that we have are involved. Cost, capability, other elements. And those are hard decisions at times, and those are decisions, though, that need to be made. Okay, as we're doing all this, we also want to continue to innovate. And you know, what is the latest manufacturing technology? So what should be considered, and how do you bring that into how you're going to bring your product to market? We want to be more productive. We need to lower costs. I already showed you that we're off our cost target. So we need to do something, right? And this is one way to do that. And so some of it we you know, kind of focus on as we go. Advanced coatings. We've got coatings that we're going to bring into the product line that we're you know, finishing the development on. Not finished yet. Okay. Some of it is know-how, taking the latest and greatest machines, very programmable, you know, very precise, and using our know-how of how to machine hard metal, bringing the two together to help reduce cost. Okay. But the question of what more do you need to do to take, say, your cost or you know, a capacity challenge that you might have in making your product may require further development from just qualifying the product itself. Okay, we don't necessarily solve all problems, and we also need to seed the future. Okay, and so here in this area, Pratt Whitney collaborates and works with University of Hartford, so the metrology lab and precision engineering, coursework. As Nantucket Community College, so we use that to help train our technicians. You know, it could be on new equipment or quality, statistical methods, you know, just big, some of those more basic things that are very helpful for us. In times past, Pratt Whitney might have done that themselves in-house. Okay, but there's a cost to doing that, and that's not really our specialty. These school like as Nantucket can do a great job, do it much better than we can, and it makes it very affordable for us to help people get more training than they have. Goodwin College is really focused, you know, in the manufacturing arena and bringing machinists and technicians along, and we're working with them. Central Connecticut, and then the University of Connecticut. So, as you're thinking about, you know, what are the challenges, you know, it has to be, it should be broad-based. How else can I get problems solved? Or, you know, what are the other channels that we should be developing so they're there for us when we need support, help, and ideas for change. For making the jet engine, critical capacity generally revolves around the test cell. Okay, it's really expensive. One test cell could be $50 to $60 million. And then there's not a lot of people that necessarily want a jet engine running in their backyard. So where you can locate that. And so we generally, almost the first thing that we do is say, okay, we need capacity. Okay, you're going to make 1,500 engines a year, and you break that down. And one of the first things we go to is, do we have enough test cell capacity? And if not, what do we need to do? So as you think through bringing your product to the market, the question is, where is your critical capacity constraint, and what are you going to do about it? One of the things that we realize is we have customers all over the world. We have a manufacturing supplier network all over the world. We need to feed, in the end, it's going to be 5 engine centers. So all the parts that get made are going to have to go out to 5 different engine centers where the engines we brought together and then tested and then shipped to the customer. We realized that we may not be expert in material logistics. We're pretty good, we survived this long, but you know, today you get a package, you can track it the whole way, you know what hour that it's going to come, and so on. And what we decided to do, instead of investing in material logistics, in the systems, we partnered with UPS. And so they're going to handle our material logistics worldwide. From the shipping dock at the factory out. Inside, you know, we have our team, you know, working on that. And so for a jet engine part, we're going to get that same thing that we all get today on a commercial product. We will know where it is over the road, if it's going over the ocean. We will know where it is. They're using advanced warehousing techniques. They're going to run a massive warehouse where we use 200 people today. They're going to run a massive warehouse with like 25 people. Automated storage and retrieval. They're doing just fantastic things. And the thing that I learned in working through this project is, you know, specialization. We shouldn't be surprised. You know, as an industry matures, you'll get specialization. And the UPSs and FedExes of the world are expert. They do R&D on logistics. They've got, you know, PhDs on staff. They collaborate with universities. And so they came in, we told them where we are in terms of factories. We told them what we needed to move. And they came back with this map that said, you need to put a warehouse here and here. These are the routes that you're going to use most of the time. Started optimizing our costs for transportation. Just, you know, like designing a jet engine. You know, it was amazing. And so this is a big change for us, though, because today we do this for the most part. You know, we use trucking. We use some, you know, a trucking firm, but we are, you know, in charge. We call them. You got to be here at this time, and so on. And so, kind of, you know, turning over a little bit of control, but they're going to go where we never would have gone. And the investment to do that would have taken away from investing in the product, into the core of the business, what we do best. Okay, so that becomes a question for you as you go down the path. Is what will you do? Where do you need partners? Where do you need other help? And make those key decisions early. You know, making it late right before you're supposed to deliver, you know, the engine of the product is gonna be a problem as well. This is a 3-year project. Okay. So I went fast through a $7 billion project. About $4.5 billion to develop the you know, to get to where we have a product, and about $1.5 billion to industrialize. And remember, we're only making 20% of the parts. The other 80, that means the supply chain is going to invest. Now they're going to charge us back, right, in part price. So that's how they get paid back for that investment. But for us, another part of the financial thought process is you can't pull off a project this big by yourself. You need partners. You need the supply chain to invest to help you capacitize and put the capability in place. And then there's a certain amount that you have to invest. And you have to try to make good decisions about that. So listen, I know this is a really big project, and some of you may be sitting here saying, well, you know, listen, Joe, you don't understand. I'm only designing this one little thing. I think that some of the concepts here, in terms of you industrializing for your project, are applicable in some way, shape, or form. Okay, and so I'd ask you to think through that. This is not a case study for you know, educational environment. I'm living this, and the team at Pratt is living this every single day. We're doing this, and it's one of the reasons why I'm really excited about it as well. It's not that often that you get a chance to work on something that is really different in the industry, that really changes the game in terms of performance. And so just like going back when Fred Rensselaer and his team that started Pratt Whitney created an engine that changed the reliability and performance of an engine to make the airplane much more viable, which in the end opened up the entire world for all of us. Okay, we think that with the benefits to the environment, okay, lower fuel burn, lower cost to operate, will continue to help all of us be able to travel wherever we want in the world and make, you know, the U.S. and continue to make the U.S. a very, very strong, you know, economy based on this. So with that, I don't have any material, and I left a little time for questions. Thank you.
Any questions for Mr. Silvestro, please?
Was there anything applicable to your project?
So one of the things that always fascinated me about jet engines is that the exhaust temperature of the jet is higher than the materials that are powering those
Absolutely.
jets. And how is that? I'm teaching heat transfer
Yeah.
here, so it's fascinating.
Yeah. Well, the jet engine, the technology, there's cooling. So we do two things. One is a lot of the parts that are running in the gas path, that are the gas is really hot because you're burning fuel. The metal is top notch. I mean, you know, it's, you know, a nickel alloys, really high temperature to start with, but the parts are hollow, and so you run air through them. Okay. The other thing that we do is we put a coating around them, so like a ceramic coating or other types of coatings. So we hold the heat out, and then we take it away, you know, with the air. And so, yeah, in the hottest parts of the engine, the parts are running in an environment that is above their melting temperature. So the cooling can't stop. That's an issue.
These things work all the time, you know.
Yeah, yeah, very reliable, very reliable. Questions? Yes, sir?
At one point you said you had a fantastic, it would be like the greatest product, but at what point do you decide that lowering the cost is more important than potential maximum of the product, quality maximum?
Yeah, I mean, the market, you know, the market helps you because as soon, you know, as soon as you go and you bring something, the competition is not going to let you necessarily walk away. And so a price point, you know, is kind of established because the customer is looking at their business case. Okay, I can do a new airplane, okay, but I'm only gonna be able to sell it, you know, for this, and the engine system is gonna be worth about this. So a price point is set. But what I will tell you is what we don't necessarily want to do is you could increase your market rate, the amount of the market that you have, by lowering your cost, okay, and then you sell more, okay, then you get the economies of scale. But then the cost is, you know, the cost that you're taking on is actually, you know, quite high. So there's no, I would say, perfect, you know, calculated point. There's just considerations to, you know, how much do you want, how much risk do you want to manage, you know, in terms of the business case. It's not a perfect answer to your question, I know, but there's, you know, those are the considerations. We're in a very different kind of a market, because in the end, there's 3 companies that make big jet engines. General Electric, Snecma, which is a French company, which is a joint venture with General Electric. So we kind of call them one, even though it's 2, Rolls-Royce and Pratt & Whitney. Okay, and so it's not a like a true commercial, you know, environment in the sense you think about commercial products. So things kind of stabilize relatively quickly in terms of what, you know, the viable cost is for the product.
It seems like there's not a whole lot of competition. Like your competitors are big. It's not like there's 20 other companies you have to deal with.
That's right. Yeah, this is a market, you got to have big pockets. And really, you got to have expertise. I mean, this is not a, you know, just jump in, you know, kind of thing like SpaceX, Elon Musk, right? If you know anything about those guys, they jumped into the market. You know, they had no expertise, but what they did is went and hired, you know, experts from Boeing and so on, brought them on, and, you know, was disrupting, trying to disrupt the market, you know, by bringing the spacecraft and engines to change the game. It's costly though. And by the way, just so you know, that happens to be the industry I was working in before I came back to jets. A lot of government funding and a lot of NASA funding. So that wasn't like it's billed as a private enterprise. The government, I think they finally paid the government back. You know, I think NASA is still a big contributor. So to get something like that off the ground still requires, you know, deep pockets like from the U.S. government or others. Other questions?
So Joe, I mean, I thought you had a good point. You price yours based on what the plane more or less has to sell for. So isn't that, because you have to fit into that. In other words, people just can't afford to pay 20% more for airplanes, even if the fuel economy is better, because then that disrupts their whole business plan of sort of the recovery. So I think sort of costing out and understanding the cost of the system that it goes into, which is here, you know, the jetliner, helps you to sort of set a cost point, and then there's always pressure then to reduce that. I think that's what you said, is that.
Yeah, I did, thank you, and that's what I mean. Like, just one simple way to think about it is if we can provide for an aircraft $1 million a year benefit in fuel consumption, and then you can put some other dollars on there for lower maintenance, you could do, and then the aircraft is going to be, what, 20-year life? Right. You could do a net present value, and then say, okay, that's worth today this, and then, so therefore, you know, how does that fit into the aircraft system overall, and where does that put that? So there's, you know, different ways that the airlines look at the product, and when we look at the product up front to say, what do we think we could sell it for, you know, and, you know, they kind of converge. But you can see they didn't converge perfectly because we're still trying to close, you know, the gap in terms of where we need to be.
But airlines, I know that they technically don't own the engines, they rent them. So when you guys come out with a new engine, do you offer them an alternative for when they come, when you pick them for maintenance, or do you have to offer them like a whole new jet because of new thrust power, put strain on the wings, or how does that whole system work?
So airlines generally do own the engines. Okay. What we do is we work to manage the maintenance, so that they don't need a maintenance team. So they have, it's kind of like if you want a car and includes the free maintenance for 5 years. So that's generally how we do it. No, aircraft, and you know, I was showing the chart that had like the 17 to 24,000. the aircraft is certified to that, and you can't change that. Or you can recertify it.
All you
Okay?
need is like a safety net.
Yeah, that engine is certified with that aircraft, and that's it. If you want to change the engine type, go to a higher thrust or something like that, you have to recertify the whole system. Okay? And even if we do little upgrades, you still might have to recertify. It may not be that big of a deal. So right now, Airbus is flying the aircraft with our new engine, because we certified the engine itself. We ran it like mad, we did all kinds of stuff, we threw birds at it, we threw ice, you know, it's up in Baffin Island, they're testing it like really cold, all of those things. The engine is certified and bulletproof, but now they're certifying the system. So they're flying the new aircraft because they had to do some work on the wings and do other things like that, and they've got the engines which are certified, and Airbus is currently out in France, they're flying the aircraft, they're doing all kinds of things to it, wacky, really wacky things. I mean, they go up to 40,000 feet, they shut the engines off, and then they come back to say 30,000 feet and try to relight the engines. Make sure, because that, you know, you never know, something could happen. In flight, they bring in at really high angles of attack, trying to stall the engines, you know, because you just never know what could happen. And for all of us, you know, I fly a lot. I don't care what they do in flight tests. They just have to do everything, you know? Turn it upside down and do everything. Because you never know what's going to happen. But to your point, I mean, that's a very serious thing. You just don't take another engine and stuff. And that's why it's, you know, hundreds of millions of dollars, $1 billion to do some of this stuff. Other questions? I know you're about to run out of time. You got a couple more minutes. Yes?
I have one question that's slightly not related, but as coming from University of Hartford, do you have any tidbits of advice for most of these are sophomores in engineering?
Great question. Thank you. I should have covered that. So, I started by saying, can you imagine, I never would have imagined that mechanical engineering at the University of Hartford, next thing you know, making jet engines, making rocket engines. Wow. When we talk about anything is possible, I would say that's anything is possible, and specifically for myself. I'll tell you, I you know, having been an engineer, I am an engineer, but having gone through the education, you know, now, I have never looked back. It has served me well in my personal life and in my professional life. Probably amongst all the best, good decisions maybe that I've made, this was one of them. So you're in your sophomore year, it's getting hard, it's going to get harder, press on. So I'm saying to my son right now, press on. You have to. But it's great. You'll never, even if like I went and got a business degree, even if you decide to do something else, you're never going to be sorry for having become a graduated engineer. My personal view. Now, you know I'm biased. But here's the thing. University of Hartford. I'm sorry, Dean, about what I'm going to say. This is not MIT, some of these really big names in engineering. But guess what? Pratt & Whitney, the premier aircraft engine provider in the industry, hires engineers from the University of Hartford. Okay? Good, solid engineers, great engineers that go on to do great things for the industry and the country. Okay? So, you know, anything is possible. You just got to keep pressing. And, you know, today, you know, in the business, every day we have challenges. And some days I don't think we're going to make it to the end of the day. You know, it's like, we got to do this, we got to do that. We got so many things going on. I don't understand this problem, all of these kind of things. But continuing to press hard, you will be able to make it happen. And the education that you're receiving here at the University of Hartford is equipping you to do anything that you need to do. So, any other questions?
Well, Joe, we thank you. You're a credit of what could be done without degree. Thank you so much.
Yeah. Hey, good luck, everybody.
Right, everyone from my section, make sure you check off the sheet. There you go.
All right.
Oh, yeah.
Yeah, that was terrific.
I don't know, did that last comment I made come up, okay, I didn't really, I wanted to, make the point right higher for all of it. Maybe that's correct. That's true. It's good. Yes, thank you, thanks. Was it, was it going to apply? Oh, yes.
The whole idea is you don't have to make logistics. Those cars have to get to somewhere, to get to somewhere. That's why most people will.
Yes, I
They
agree.
don't understand that they think that their company has to make it from the screws.
Yeah, no, it's true. It's, we was really an eye-opener for us when we started. Yeah.
I hope everything's all right.
Right, that's true. Yeah, so, and that's the thing that we're trying to get to the right balance. I don't know what 20% is the right number, but when we look at the investment and actually on package now, at 20%. Yeah, so, and you carry the risk associated with that kind of infrastructure.
So you were saying, airline companies don't own the engines, or
They do. Majority of the time they do. They can lease engines. There's a big leasing, element. But when you look at in totality, the airlines, generally the aircraft manufacturer will offer 2 engines. Okay? And then the airline selects the engine that they want to have, and so on. So that's why there ends up being engine competition.
I know, one of my status professor and salesperson was talking about how the $10,000 titanium blades get deformed and how it's cheaper to have the engine rented so they come in and shop and they bring a new one.
That's a strategy, and it depends on what your the airline's business case is. Like JetBlue has no maintenance capability at all. We handle it. We handle it for them. So, like when they're ready for a new engine, our team drops it off, and then we put another one on, and then we go and take care of that. Delta, they've got a big shop. Yeah, down in Atlanta, they got a big shop, and they do some of their own maintenance and so on. So it varies. And we were just talking about the make and buy. So airlines are making those decisions as well in the same way, but still predominantly, they own. But they're like the new thing is that they secure maintenance agreements.
Oh, okay.
Your product, you got to think about this make buy. How much am I going to make all of it? Am I going to make some of it? Who's going to make it for me then? What relationships do I have?
I have one quick question. It's kind of a personal question.
Okay.
Why, there's a difference between an MBA and a master's degree, right? So why did you go for your master's, your MBA and not your master's?
You mean the masters of
Yeah,
engineering?
engineering.
Well, so at the time, the company, was saying, hey, listen, you're going to probably spend a lot of time really running the business. So what I do today is I run the business, and it's very important for you to understand the concepts that are going to be successful to keep us afloat. A lot of accounting, finance, strategic business, like positioning of products and marketing, all of those type of things. So they're like, you're not, my path is not necessarily going to be chief engineer. We need you to have a couple weeks ago. Financial access. So it depends on, what career, because if you're going to stay in the engineering track.
Right.
You get a master's.
Right. I remember.
But guess what? There's a lot of guys that have masters of engineering that end up becoming businessmen. But that's why.
Pushing for him to.
You work for a while, because I did my.
That would be good, yeah.
I graduated from